Hello everyone, welcome to my channel Data Analytics. I am your host Professor Rage Uday Kiran. In this video, we are going to cover the topic knowledge discovery in big data. This is a basic topic which will be covered in depth in this video. We are also going to provide a demo on this topic using the real world data. The outline of the presentation is as follows. First, we discuss the origins of big data. Next, we describe the framework for knowledge discovery in data. Then we try to fill in the background information necessary for understanding the demo. Finally, we provide the demo explaining the each step in knowledge discovery in data. Origins. Thomas and Robert have interviewed many entrepreneurs in America and reported a important problem faced by them. That problem is data rich, information poor situation. So, what is this problem? So, the problem is that the e-commerce companies are collecting massive amounts of data from their customers. However, they are unable to extract the useful information from these large data sets because the statistical techniques which were primarily designed and developed for small data sets were unable to cater the large data sets. To solve this problem, researchers have introduced a new topic called data mining. The objective of this new field is to come up with scalable solutions that can discover knowledge from big data sets. This field, that is data mining, over a period of time advanced and took many names. For example, it was later called knowledge discovery in data, later transformed to big data analytics, and recently it is being called data science. Whatever the name, the sole objective of this field is only one, that is discovering knowledge from big data. So now let us look at the framework of extracting knowledge from the data. So this framework, which is popularly called KDD, has 5 steps. The first step is, first we have the data. From this data, we select the portion of the data that is of interest to us. So this is the first step, selection. In the next step, we do the pre-processing of the target data and then generate the pre-processed data. In the third step, we perform transformations. For example, converting the format of the data or normalizing the attribute values in the data and then create the transformed data. This data is then fed to the data mining or machine learning or deep learning techniques to extract useful information or patterns. These patterns or information will be later interpreted by the humans or machines to benefit from the knowledge. So this is the process. We will have a demo in which we will go through the each and every step in the KDD framework. Before going to the demo, it is important to know what is the application that is producing this data. Otherwise, it will be hard to understand the context. So, we are now going to provide the basic information on the data we are going to use in the demo. Japan is facing severe problems with air pollution. Every year, thousands of people are dying due to bad air. To improve the air quality in Japan, the Ministry of Environment has set up a system, particularly a sensor network, to monitor air pollution throughout the Japan. This system regularly gathers the data on various pollutants such as PM 2.5, SO2, and so on. For demo purposes, we are going to focus only on one air pollutant, that is PM 2.5. So this is how the system produces the data. As you can see in this figure, the red dots represents the sensor locations where PM 2.5 values are being recorded. So this sensor network gathers hourly data for each sensor. So you can see the timestamp where we are collecting the data at each hour, and P00 represents the sensor's location where the measurement is being taken. If the sensor's location is not known to us, we will have unnamed column. So this is how the data exists. Now, the domain experts such as policy makers and environmentalists want to find useful information in this hourly PM 2.5 data. For example, domain experts wants to know the locations where people were frequently exposed to harmful levels of pollution. So in the demo, we try to cater the needs of this domain expert. Now coming to the demo. So how do we identify which sensors are recording high levels of pollution? For this, we are going to use the standard scale specified by the Ministry of Environment, Japan. According to this scale, PM 2.5 values greater than or equivalent to 35 are unhealthy for the users. So we are going to use this scale for our demonstration purposes. So this is the entire knowledge discovery framework that is provided here. Okay, so each of these step we are going to give, we are going to do in the demo. The demo has been done in the Google Collab and the link is provided in the description. So this is the KDD process, and this is how we are going to perform the big data analytics to discover knowledge in the air pollution data. We now look at each of these steps. In the first step, we are going to download the data from the Dropbox link provided here, like this. We can download the link. Once we have downloaded the link, what we are going to do is, using the pandas data frame, we are going to read the file and display the contents. As you can see from this data frame, you can see that we have collected hourly data from 2018 101 to all the way 2023 425. That means we have 5+ years of air pollution data gathered throughout the Japan. So the total number of rows in this data is 46,000, and the total number of columns is 1832. Now when we look at the columns, the first column is the timestamp and the remaining columns represent the sensors locations. If we go to the edge, we can see that there are some sensors that do not have location information also. So this is our data. Okay. Now what we are going to do is, we are going to use this data for knowledge discovery purposes. So domain expert is providing us this data set and is requesting us to identify the locations where high levels of pollution were being observed. So the first step in the KDD process is selection. That is, given us the data, we have to create the target data. To create the target data, what are we going to do is, we don't need the timestamp information because we know it is collected at every hour. So we can remove the timestamp information, and also we can remove the sensors that do not have location information. Okay. So here we are going to remove the timestamp information from the data set, and then we are also removing the location information here. As you can see, the number of columns were reduced from 1831 to 1764. Once we have the data set, target data set, now we are going to perform the pre-processing. In the pre-processing, first what we will be doing is, if we find the NaN value, we will replace them with 0. Next, we will find the abnormal values, that is values that are very high and the values that are very low, and then we try to replace the values with 0. So in this case, what we are doing is, we are taking the data set and filling the NaN values with the 0. As you can see here, the NaN values were reduced to 0. Now coming to the abnormal values, what we are doing is, we are checking the maximum value recorded in the each column, and then we are displaying the graph. As you can see, PM 2.5 values more than 10,000 can be seen. Generally, PM 2.5 values in Japan are not more than 250. So these values generally represent the abnormalities in the data that was captured by the erosion of sensors. So what we do is, we simply replace the values greater than 250 to 0 because the data is useless for us. Now, when we plot the maximum values, we can see that all the values are within the 250 value, which is quite good, and that is what we need. Next, maximum we have checked. Now, let us look at the minimum values recorded by the each sensor. When we plot the minimum values, we can see that minimum values for the sensors were negative also. PM2.5 values cannot be negative. The minimum PM2.5 value is going to be 0. That is whether there is a pollution or no pollution. There cannot be negative pollution. So what we try to do is we simply replace the values that are less than 0 to 0. Now you can see that the minimum value recorded by the sensors is 0, which is what we need. Once we perform the, the abnormality removal, then what we are going to do is we will convert the data frame into a transactional database so that we can input this transactional database in the later step to a pattern mining algorithm and discover patterns. To convert the data frame into a transactional database, first we install the PAMI library using the pip command. After installing the library, okay, we use the data frame to database subpackage in the PAMI library and create a transactional database. Okay, so how are we creating this database? We are telling that given this data frame, create a transactional database if the sensor values are greater than or equivalent to 35. So using this condition, we are creating the data set, transactional data set. If I print the contents of this transactional data set, every line represents the sensors that have recorded high levels of pollution at a particular time. If you want to know more about the transactional databases, please check the link provided above. Now we have the transactional database. To perform any data mining task, it is important to know the statistics of a database, such as what is the size of the database, how many items the database contains, and what is the distribution of the database. So if we look at these details, we can see that this database has 31,462 transactions and the total number of items are 1119. If we look at the sparsity, we can tell that this is a very sparse database. It means most of the cells in the data frame are zeros. And we can also look at the distribution of items frequency values. We can see that many items are having very low values. Similarly, if we see the transaction length, we can see that many transactions have items not more than 20 or 25. So this is the information we get from the transactional database. So this is useful to specify the minimum support value. So value for frequent pattern. If you do not know about frequent pattern mining, please check the link provided above. So now what we are going to do is we are going to use the frequent pattern model in the PAMI library and then we extract the patterns. So these are the statistics of the mining process. Once we got the patterns, next what we are going to do is we are going to visualize the patterns. So we have the patterns. We are trying to visualize top K long patterns in the generated frequent patterns. So we took the patterns and then we are trying to visualize. So these are the locations where high levels of pollution was observed. Okay, on the north side there is only one sensor location where high levels of pollution was observed. Since there is no other sensor close by, we can be lit ignorant because we can ignore this information because it will not harm much. Whatever the pollution is being recorded, it will not create much of the problem. However, if we see here at the Tokyo area, many sensors are recording high levels of pollution. Means people lying very close or in line with these sensors are frequently exposed to harmful levels of pollution. Similarly, if we come to the bottom part of the Japan, that is Kitakyushu area, we can see that many locations are frequently observing high levels of pollution. Such information is very useful for the domain experts because now the domain experts can come up with location specific policies to control the emissions. So, this is the application of KDD in the real world. That's all for the demo. This is the entire chart. If you want, you can pause the video and take a look at the entire process of KDD. Thank you very much for viewing our video. If you like this video, please press the like button, share it with your friends, and subscribe to our channel for more interesting updates. The material we have used in this video are provided in the GitHub link provided in the description. Please take a look at it. Also check this playlist for other interesting topics on big data analytics. Thank you.